Economics Tutoring Center at ASU, and today we're just going to go through a quick understanding of a normal distribution and understanding what the standard deviations of that would look like. So here we have a function of z, which is just the normal distribution, and on the x-axis we have all the z values. And so what each of these means, like this 1, 2, 3, is these represent the standard deviations away from the mean. So for example, if you were one standard deviation away from the mean, 68.27% of the area under this curve would fall between these two columns. And then for 2 standard deviations away, 95.45% of all this area is held between this area. So you'd be the whole thing. You include it all the way to the mean. And then almost 99.73% of the area under the curve would fall between 3 standard deviations, and then everything else, the 100%, is just the extra area at the end. So let's say, for example, you have a z value of 1.96. Well, 1.96 would fall right about here, so pretty close to 2 standard deviations away from the mean. So then you would say that it'd be close to 95% of the area under the curve would fall there. Or your value that you'd pull off of the z-table would be 0.95. So for the value of 0.95, that's true for a 2-tailed test. But typically in your classes, you'll only be looking at 1 tail. And just in case a refresher, these tails are like the end areas of the curve that's not counted. So when you find the 0.945, you find this whole area, and these are the little tails that aren't counted. So it'd be like if you take this area, so the 1 minus 0.9545, you'd get about 0.05, and that would be the collective area of both of these. So it'd be 0.025. And this is relevant because in your classes, you'll typically just do a 1-tailed test. So if you do a 1-tailed test, you're only counting this space, not both of the spaces. Therefore, this z value, or this area under the curve for a z value of 1.96, instead of being 0.95 when you had the 2, it changes to 0.975 to include that you only had 1 tail, and that's like the area of the tail. So it is different for your classes, but this is just the general understanding of like what the standard deviations mean. So we'll go and we'll look at a z-table for your classes, and we'll find these values so you have a better understanding of how to use it. So this is similar to a table you would receive in one of your classes, and if you notice in this little picture, it's only including one of the tails. So it would be like the last example that I said, that instead of for 1.96 you get 95 or 0.95, you'd get the 0.975. So let's find this on the table so it makes more sense. So if you look at this picture, again, there's only one tail. So if you go down to 1.9 and then you go over to 6, which is at the top here, you'll get 0.975. And again, that would just be the total area under the curve for that particular z value. But you can do this with any z value. So let's say you wanted to find, or you were presented with a z value of 1.64, but typically you'll see it as like 1.645, which would be 95% of the curve, because if you go to 1.6 and then you go over to this 4 or 0.04 and 0.05, you'd get about 95% or 0.95, 95% of the area under the curve. So these are usually the ones you will use in your class, is 1.96 and 1.645, because they represent 75% and 95% of the values under the curve. And you'll use this for confidence intervals and just like finding any z-score. But if you notice, any z-score you look up on the table has a corresponding percentage of area like under the z curve, which, see, if you look at this thing, it says table entry, and all the shaded area, that's the area you're calculating. So all these values represent this shaded area. So just to clarify then, if we had a z-score of, let's say, 0.92, then at 0.92 you'd go over and you'd find the value, And so you'd have the area under the z-score for 0.92 to be 0.8212, which is just 82.12% of the whole total area of the curve would be within that range. And so you can do that for any z-score you get. You can find a value of the area. Well, I hope this helped, and if you have any more questions, please visit us at the Econ Tutoring Center.